Hello everyone, I am Wenxi, a former DataX student. So today I will walk you through this module, Introduction to Neural Network by a notebook, to give you a better understanding of neural network with TensorFlow and Keras. So in the lesson module, we have actually introduced the TensorFlow to you, and we are using Keras. This is a TensorFlow's high-level Python API for building and training deep learning models. We're using Keras because it's modular, powerful, and it is fully functional with TensorFlow. You can just import all of Keras functionality by typing tf.keras. So let's start by an easy example of the ARIS dataset. So the ARIS dataset is a flower classification dataset. And before we train a model, let's do the data pre-processing. So first, we should import the datasets from sklearn and load ARIS here. Okay, so let's have a look of this dataset. You can see that there are in total 150 instances, and each of them has 4 numeric attributes, including the sepal length, sepal width, petal length, and the petal width. There are totally 3 classes of the irises, like here. And you can get all the features of the data by inputting the data, and the target is for the training, is for the label of each data point. So you can see that if we call Y, there's 3 data classes in total, 0, 1, and 2. And let's have a look at what is the data feature like. So for each of the flower, there is 4 different numbers here, presenting the 4 features of each flower. And another thing that we should do for the data pre-processing is one-hot encoding Y. So for now, Y is label encoding. There are 3 numbers in total, but this can be easily misinterpreted by the algorithms because actually there are no order of the 3 kinds of different irises. So let's call the get dummies from the pandas module. And if we do this, you can see that the Y for each one just changed to a list including 3 numbers here. And we can see the first 5 flowers are all from the first class. So now let's do the training test split. So we can import this module and include your X and Y as arguments. Test size here is 40% of all data. Don't forget to randomize them. You can have a look at the shape of each data here. We have 90 training data points in total and 60 for the test data. So let's do the model part. In Keras, the simplest model and the most common model is a sequential model. You can assemble the layers to build models. It just allows us to build the neural networks like Legos by adding one layer on top of another and swapping the layers. So what we should do is to import the sequential from the Keras models and initialize it by an empty sequential model. So you call it, but without any other arguments. And when you want to add more layers, you can just use the add function. But notice that for the first layer, you have to specify your input shape. This is necessary. So let's construct a model here. As you can see, we should first import a dense because we are adding the dense layers. And here in total 2 layers. The first one with the activation function of ReLU, and don't forget to specify your input shape. We have 4 features. And the second one, by the way, the units here is output space of your layer here. So you are going to output 64 as an output space after this first layer. And then the second layer will use softmax as the activation function. And it would output 3 because we have 3 classes. So after contracting this model, we also have to compile it. There are 3 arguments of the compiling of a deep learning model. Before training it, you need to configure the learning process. So the first 3 argument is a loss function. This is the objective that the model will try to minimize. You can use the categorical cross entropy or MSE, etc., or it can be a not objective function. The second argument is your optimizer. So this could be a string identifier or an existing optimizer like gradient descent, RMS prop, or Atom here. And the third one is optional. It's a list of metrics. For any classification problem, you will want to set this to accuracy. So let's run this. Okay, after compiling your model, oh, by the way, there are actually a lot of optimizers that you can use. If you want to know more about the optimizers, you can just click this link and they will tell you more about the optimizers and their trade-offs. Okay, so after that, let's train our model now. Usually we'll use the fit function to train a model. And here you have to specify the epochs and the batch size of your model. The number of batch size is the number of samples processed before the model is updated. And the number of epochs is the number of complete passes through the whole training dataset. We have in total 90 samples, and we can see that as the process going on, actually the losses is decreasing and accuracy is increasing. And here we got a high accuracy of 0.96. So we will call the evaluate function to evaluate your model on the test set. And then if you want to predict on the new data, you can call the predict function. This will return the probabilities of your data belonging to each of the class we have here. So we can see the first one, if we, the first flower has the largest probability to belong to the second class of arrows. Okay, that's it. That is all for our first example. And now let's come to the second one, the Mnist data set. So this is the most classic neural network data set, and we are going to use that to recognize handwritten digits. The Mnist data set is actually very large. It is already split into 60,000 data points of the training data, which is Mnist train, and 10,000 points of the test data, which you can get by Mnist.test. And each Mnist data point has 2 parts. This is the first part, an image of a handwritten digit and a corresponding label. And each image is 28 pixels by 28 pixels. We can interpret it as a big area of numbers like here. So the number is actually the gray level of each pixel. Okay, so actually we can flatten this area into a vector of 28 times 28, which is equal to 784. Let's load in the data first. You can get a better understanding of this database by clicking this link. First, let's call the Mnist data and split it into the X train, Y train, X test, and Y test. So if you look at the data set shape, we can see that there are 60,000 of training data and 10,000 of test data. And this is what each data point is like. So it's 28 by 28. And the min and max value of each number and array is actually the gray level. So the min value is 0 and the max value is 255. Here, if you use a gray level to show the image, you can see that this is what it's like. All right. So the train output shape is 60,000 and the tested output shape is 10,000. And there are 10 digits in total, so the unique labels are from 0 to 9, and the first 10 outputs are like this. So if you're looking at the data set, let's pre-process with the data. First, we want to normalize the data by dividing 255. That way, each of the number will be shrinked to between 0 and 1. And then we want to flatten the inputs by let it goes to the 784 instead of 28 times 28. So it's from 3D to 2D. And also we want to convert the data type as a type of float. And then we will do the same thing from the first example we had. So import sequential, import dense, and here we have more layers than the first example. But first, you also have to initialize your model by giving the empty sequential model. And then here we have similar layers here. The first 3 layers are actually similar because they are all using the value as activation functions, but with different size of output space. So the output space is decreasing each time. And the final layer is using the activation function of softmax, and we are outputting the 10 digits. After training it, after doing the sequential model, we have to compile it. So now we're using the loss function of the sparse categorical cross entropy and the optimizer of the RMS prob. So this is also a classification problem. We are also using accuracy as a metric. Okay, finally we have to train a model. So we are setting the number of epochs of 5, batch size of 64, and we got 20% of the training data as a validation. So because we have a lot of samples here, it is slower than the first one. But also because of this, the accuracy is already very high in the first epoch. It's dot 0.92. And okay, we have finished with this. And at last, the accuracy of the training data achieves 0.98, and the validation set is also very high here. So let's evaluate on the test set. Also, we can get the test accuracy of 0.976, which is high too. So there's a very little chance to be overfitted. And if we have a look at the accuracy, how the accuracy changes with the epoch, we can see that there is a trend of increasing. So we can see that if we have more epochs, actually it helps the model to be trained better. Okay, so that's all for the second example here. Okay, that's all. Hope you have a better understanding of this neural networks and how it works with TensorFlows and Keras.